Okay, number 1, 17E. The coin is tossed 16 times. The number of heads is like the sum of 16 draws made at random with replacement from which of the following boxes? So, number 1, no. Why do we not want to use number 1? There are no numbers. So, whenever we build a box, we want the box to have numbers, not words. Now, we can start with the box with words, but eventually we convert it into a numbered box. Okay, 2. Yes, that would work. 3. No, why not? We need just as many zeros and ones. What if it was 0, 0, 1, 1? Would that work? Yes. But then we have to cut out more tickets, and we're lazy. So you can always simplify the box as long as you keep the proportions correct. And ideally, we want the box to be as simple as possible. We don't want extra tickets in the box if we can avoid it. Okay, number 2, or sorry, B. The number of heads will be around blank, give or take blank or so. So we have a 0, 1 box. So the sum of the box is 1, which means if you play this game twice, you're expected to earn $1. Okay. The average of the box is going to be 0.5, which means you're expected to earn 50 cents per draw. The SD of the box, can I use the shortcut? Yes, because there are only 2 types of tickets in the box. So I do big minus small times the square root of the small fraction times big fraction times the small fraction. Do I want to plug that in my calculator? No, because I know the answer is going to be 1/2. How did I know it's 1/2? How far away are the tickets in the box from 1/2? 1/2. So anytime you have a 0, 1 box, the SD will always be 1/2. Every single time. What if I had a 0, 0, 1, 1 box? It's still going to be 1/2. Because the tickets in the box, on average, are 1/2 away from 1/2. Okay. All right. So I want to play 16 times. So if I play 16 times, my estimated value is 8. Where do we get 8? We take 16 times the average of the box is 8. Plus or minus how much? Well, the SE is going to be 1/2, which is the SD, times the square root of 16. So 0.5 times 4 is 2. 8 plus or minus 2. Okay. Number 2. 100 draws are made at random with replacement from the box 1, 2, 3, 4, 5. What is the chance of getting between 8 and 32 tickets marked 5? So I don't want to use the box they gave us. What box do I want to build if I want to count 5s? How do we build a counting box out of a numbered box? 4 zeros, how come? So if I draw 1, do I count it? No. So a 1 is worth 0 points. What if I draw 2? It's also worth 0 points, and same with a 3 and a 4. What if I draw 5? It's worth 1 point. So I have 4 copies of 0, and I have 1 copy of 1. That makes it nice. Now I can use the SD shortcut. So The sum of the box is 1. The average of the box is 0.2. The SD of the box is simply 1 minus 0 times the square root of 1/5 times 4/5. And we don't need to subtract 0 or times by 1. So it's simply the square root of 0.2 times 0.8. I get 0.4. So on average, the tickets in the box are 0.4 units away from the average of 0.2. Okay, we're going to draw 100 times. So D equals 100, which means that the SE is going to be 0.4 times 10, which is the square root of 100, which gives me 4. If I draw 100 times, what am I expected to earn? 100.2s, which is 20. So my average is 20 plus or minus 4. So I want to know the chance that I earn between 8 and 32. Oh, how nice of them. Why is that nice? It's 3 SEs. This distance is 12, and this distance is negative 12. My SE is 4. So what percentage is between positive 3 SEs and negative 3 SEs? 99.7. That's our memorized rule. Okay, if you don't remember that, you can always shade norm from negative 3 to 3. All right, number 6. A coin is tossed 10,000 times. What is the chance that the number of heads will be in the range 4850 to 5150? If I'm counting heads, what's in the box? A 1 and a 0. That's it. In a 1-0 box, the sum is always 1, the average is always 1/2, and the SD is always 1/2. And we're going to be using these a lot, so you can just remember average is 1/2, SD is 1/2. I'm going to play 10,000 times. So my expected value is 5,000. And my standard error is going to be 1/2 times the square root of 10,000. The square root of 10,000 is 100. 100 times 1/2 is 50. So my curve is 5,000, and I want to go from 4850 to, is it 5150? Yeah, 5150. Which means 99.7. How come? It's 3 SEs away. Okay? All right, we play 1,000,000 times. So 1,000,000 times, the square root of 1,000,000 is 1,000. And we're going to times that by 1/2, and I get 5,000. So my curve now has 500,000 as the expected value. What's the chance that I'm 501, 500, and 498, nope, 48500? What do you notice? It's still 3 SEs away, 99.7. Now, what I want to point out here, and this is kind of what they're getting at, let's just look at these 3 curves. So when we played 10 times, we had, what was it, 20? 8 and 32. Every one of those gave us 99.7%. But look how far off this is. That's 12. 12 over 20 is 60%, right? 2 standard errors is 60% of the average. Okay? Now, this is a distance of 12, and this is a distance of 150, right? So in absolute terms, this is more spread out. It's minus 150 and plus 150. But in relative terms, 150 divided by, oh, it should be 10,000, sorry. So this one should have been 12 divided by, oh my goodness. Sorry, it should have been 12 divided by 100 draws. So that one is 12% off. 150 divided by 5,000 is only 3% off. And this one, even though it's 5,000 off, 5,000 divided by 1,000,000 is only 0.5% off. So does that drive home the point? The more you draw, the further away you're going to be from the average in absolute terms, but the closer you're going to be in relative terms. Why is that the case? Because when the draws go up, the standard error increases by the square root of the draws. So the error is growing at a slower rate than the draws are growing. All right. And 7. 50 draws are made at random with replacement from the box 0, 0, 1, 1, 1. There are 33 ones among the draws. The expected number of ones is blank. The observed number is blank. The chance error is blank. And the SE is blank. So we have 2 copies of 0 and 3 copies of 1. So the sum of the box is 3. The average of the box is 3 divided by 5, which is 0.6. And the SD of the box is going to be 1 minus 0 times the square root of 2/5, which is 0.4, times 3/5, which is 0.6. So the square root of 0.4 times 0.6, oops, wrong button. And notice it's really close to 1/2, 0.489. 0.489. All right. 50 draws are made at random with replacement from this box. The expected number of ones is going to be 50 times this. So 50 times 0.6. I'm expected to get 30 plus or minus how much? 0.489 times the square root of 50. So 0.489 times the square root of 50. So plus or minus 3.45. So I'm expected to get 30 plus or minus 3.45. The observed number, the actual number of ones, is 33. The chance error is, how far off was I? 3. And the SE is actually 3.45. Does the box seem fair? Totally. That is totally within the window. So we would say, well, we would say we can't prove that the box is unfair. That's kind of how we do things.